In part 4 of our Eliminating Loops video series, we're going to wander over into the tidyverse and see what's available there to help us eliminate loops. Here's a data frame with 4 variables with random normal variance. We could calculate the medians of these columns separately, like this. That's fine, but what if we had 100 or 200 columns? Then we could use a loop. We start by initiating a vector of type double, and with the same number of items as the number of variables in our data. Note the use of the sequence along function. This is a nice function for indicating that we want I to sequentially index across the variables in our data. So here is median vector. I'm going to create a vector that's a double based upon the number of columns that we have in our data. That's the tibble that we created up here. So those are going to be placeholders. Now, rather than saying for I in 1, 2 something, I'm using a tidyverse function that is sequence along, and that simply tells us that we want to move along the columns of our data. That's a nice little function to keep us from having to figure out 1, 2, how do I say what the end of this is? So let's go ahead and run that. And we saved it all in the median vector, which we can look at. Here it is. There are the medians for the 4 columns of data. Now that didn't eliminate the loop, but what it did allow us to do is to show a nice little function in the tidyverse, sequence along, if you still need a loop. That's going to work for any number of columns we have in our data frame. But the map functions in the tidyverse really make this easy. This is how we can eliminate loops. These are functions because there are different functions for different types of data. Map underscore DBL is, as you might expect, map for double. So let's do what we tried to do right above by using our data and median, and here we get the answers. The nice thing about the tidyverse functions, unlike the apply functions, is we can pipe our data. So we could put this in the midst of a number of other things we are doing. Like for instance, if I needed to use these medians in a graph, I could pipe the result into a ggplot2 function. So let's do this. And you see, the results work just nicely. We could use map if we want a list instead of a vector, but that's probably not what we want here. But if I had used map instead of map double, this is what I would have gotten. I would have gotten a list. Now let's look at how we can use the tidyverse split function with mapping. The split function takes a single data frame and splits it into a list of data frames. Remember when we used tapply before? Well, we can do even more powerful things here by using this split function. So here I'm going to create a car list in which I split cars by cylinders. Let's look at it. Notice that I have 4-cylinder cars, 6-cylinder cars, 8-cylinder cars. Now let's look at the relationship of gas mileage to weight of the car, but we're going to do it separately for each cylinder. So we have to indicate what our data set is, but we can do that using this period. The period simply means use whatever the current list item is. A list item here is a data frame. So we don't have to indicate what type of data we have, just say use the current data. So here's car list. Remember again that that's what I showed you up here. That's the list of cars. We're getting the linear model of miles per gallon as a function of weight using that list. Here we go. Look what you get back. You get back the coefficients for a linear regression for 4-cylinder, separate coefficients for 6-cylinder, separate coefficients for 8-cylinder. One of the really cool features of the map function is the ability to extract components of lists. Let's create another data frame of normal variates, but this time use a different mean for each. Here I'm creating our data. I'm going to use normal deviates again, but notice what I'm doing. I'm using 0 and 10 for mean standard deviation. I'm changing it to 5, changing it to 10, changing the mean to 15. This is going to give us same standard deviation, but different means for each. I'm doing that so I can show you how we could map the t-test function. Let's apply it to each column. What do I get? I get a one sample t-test for A up here, another one for B, another one for C, and another one for D. Notice the elimination of the for loop. No looping to do this. Let's do it again, but this time let's pull out all the p-values into a vector. Notice the attributes for t-test. So I'm going to do a t-test. I'm going to store it in check.t.test and look at the attributes. The p-values are stored in p.value. So look what I can do. Our data, pipe down to map t-test, pipe down to map double p-value. And here I end up with the p-value for A, B, C, and D. Pretty amazing, isn't it? Let's pull out the confidence intervals. Now the confidence intervals are themselves vectors, so I can't put it in one vector. I'm going to have to put it in a list. So rather than using map double down here, I'm just using map for confidence interval. So here if we go up to A, we see the lower and upper bounds, B lower and upper, C lower and upper, D lower and upper. We could have made that whole series of events even cleaner by using a map to generate our data in the first place. Remember, the map works on list. So we need to put our means in a list. So here I'm going to create a list of my means. Now I'm going to take my means, I'm going to pipe it down to a mapping function that gives me normals for an n of 10 and a standard deviation of 10 and put it in our data. And here's what I get. I get those 4 groups of normally distributed values, each with a different mean. This one has 0, this one 5, 10, and 15. So now we have a list of vectors. So let's go ahead and pipe our data to t-test and map the confidence interval. There we go. Let's look at the order in which we supply items to a map when we're iterating over a function. Iterating mean one at a time, like a loop, but we're not using loops. First, we send it any arguments that vary, then the function and additional arguments. So we could have done the above like this. So here I'm making a list of my means, and then what I could have done, instead of what I did up here with map R norm, is we send it first any arguments that vary. So I could have put in my means instead of R norm, and that way I could have put it right into our data in one step. What if we wanted to vary the standard deviation as well? We can use the map2 function. So here I'm going to put a list of means. I'm going to put a list of standard deviations. And now what I'm going to map are my means, my standard deviations, with the rnorm function and n equal to 10. So I'm going to now put my means first, my standard deviation second, rnorm, and n equals 10. And because it's map 2, it's assuming that I'm going to vary the first two things. And now we have data sets with different means, different standard deviations. What if we had 3 arguments to vary? Is there a map 3? No, but there is a p map function where p can be any number that will allow you to vary any number of arguments by putting them in a list, but we're going to stop here. This is a lot to digest for one day. I hope you can get the sense that even though they might take a little bit of getting used to, these mapping functions are extremely powerful ways to avoid loops. They also are allowing for piping so that you can fit them in as part of a more extensive formula in which you're piping in the tidyverse. There's also a nice cheat sheet for the mapping functions that are in the tidyverse, and so I'm going to provide you a link for that as well. This ends our series on eliminating loops. Seldom should you have to use loops, but if you ever do, I hope you know better now how to use them.